Okay, we should be live. Test sound and everything. Go check out biomedical.com. There's a lot of interesting tools. And do let me know what you think, because it's currently under development. It's all work in progress. So this is a good time to provide your feedback. You don't have to be an expert in any of those things, but if you are, that's nice as well. Shall we jump into any of the tools or develop a new one? Let's do a new one. So this is only running locally at the moment, not published yet. I don't think it's ready because it's not doing much at the moment. But the idea is to have a cochlear implant simulator. And we have the code. Let's see. We have, so it's a Flask application. We want to do as little as possible in the backend. So primarily rely on JavaScript, and only we should have a prompt like that somewhere. We do have prompts. Okay, so we have the index HTML. We meant to have, okay, we meant to have the audio canvas. I think this is it. Then we also should have a pixel canvas. This will be similar to the live simulation, but it will just be an array, much simpler, obviously, just an electrode array, 20 pixels. That will go on and off depending on the incoming sound, using a microphone ideally. Yeah, in some of the tools I have to make sure that, yeah, if you're not turning your camera or a microphone, that they still provide you something useful. Potentially would be just doing, just placing a video in there below the actual application, just so you can see how I'm using it, or even potentially how it was developed. So yeah, go check out the live simulator as well. It's currently a live on the website, available for you. Eventually, yeah, so this should be some YouTube videos that will go down here. Yeah, don't forget to share on any platform of your choice. Those don't really work well. This is something we're actually developing using Gemini Advanced. We'll pop it in here. Yes, I was asking if you can develop existing Flask application. Yeah, this will be, well, it's a new one, but we already have some code for it. Yeah, ideally all this stuff should scale so it works better on no, it does scale, but it has a minimum, so it should work better on should stop moving the windows around. if I do this, yeah, that window, yeah, because the other thing, yeah, I have this weird thing for the display. Where's that thing? I'm gonna get rid of it. Doesn't matter. I can do that offline. I need some sort of good arrangement for this. Yeah, this is running locally at the moment, not available for you yet. Hopefully it will be very shortly. This is, hopefully this scales better than OpenAI's website. Okay. And we also got a GitHub Copilot on the side screen. Obviously, it doesn't all fit into the one screen, so apologies for that. Should we continue from? Okay, so it needs to know that it's a Flask application. Then we have HTML. Now the HTML is calling multiple JavaScript files. I'm pretty sure that JavaScript, no, it only has main. So we have main over here, and I think main might be calling others. Or not. Because we also have audio processing and settings. So how does that all works? It's end of main.js. So say audio processing has set up audio notes function. And it's not called anywhere. Export function. Connect audio notes. Reconnect. No, obviously it's a template. Okay, I don't think we are currently using the settings in audio processing JS. That's fine. We have an info file. We can use you can see that a GitHub Copilot with a workspace handle. Asking to update the file and folder structure. Prompts, audio processing. What files are not currently being used? think it needs that workspace handle every time. What files do exist but not being called in the project? Okay, not references in the code, yeah, requirements, settings, JavaScript. So how about audio processing? Is audio processing don't think audio processing is being used. Audio processing JS. Yes, we know what it contains. Please note the function are not being called in the provided main.js. Okay, so it's not being used. Okay, let's start with that, see what the Gemini says. Should call it something else. Why are you suggesting to modify the code?
Absolutely. Let's enhance your existing Flask application for a more engaging Cochlear simulator experience. Here's a
Okay, I don't like that voice.
The current visualization only shows the frequency spectrum. Let's make it more dynamic by adding a real-time waveform display. This will help visualize the audio signal shape.
Okay.
Implement a basic filter bank to simulate the cochlear's frequency separation. Each band will represent a different frequency range and its amplitude can be controlled by a compressor threshold slider.
Yeah, we'll get to that compress threshold slider in a moment. I think it should be called something else.
Display the filtered output as a pixelated representation on the pixel canvas. The pixel brightness will correspond to the amplitude in each filter band, giving a visual representation of the signal processed by the cochlea.
No, I thought the field, no, the pixel canvas should be okay, a couple of things. First, the pixel canvas, the idea for it is to be a representation of the electrode array. So it should have a square for each electrode. There should be about 20 of them, and they should get activated by changing color depending on the amplitude within a certain frequency band that the microphone is picking up. Okay, another point is that we have styling file for the whole project, So the styling for this application, any specific styling for this application should be done within the HTML code. Let's go with that. And yes, we are also using GitHub Copilot. No, don't remove the... Oh, not very smart, are you? Okay, don't just get rid of stuff in the existing HTML file. We still want the current audio canvas and the filter canvas as well. I just get rid of audio processing and it still work. It's very apologetic. Okay, without removing existing elements, audio concept in a pixel. To know why it's not the same width and height, we can sort it out later. Yeah, the thing about... Okay, so that is a module. It's okay for it to be a module. Yeah, the best thing is probably a comment the thing out. Okay, we have the module now in JavaScript. So we only have one JavaScript file. We have the electrode array, number of electrodes. Set the draw function. Okay, it stopped working. A pixel canvas. This is probably something Copilot could fix. We do need the workspace handle because we meant to be looking at a different file for this. Currently in the JavaScript, but might need some changes to the HTML. Where does it go? No need to go in the beginning there. Get that error. Went away. We don't see the pixelated electrode output. Control Shift C. We have the filter canvas. Where is the pixel? Pixel canvas. Right, meant to be there. It's not really visible. A pixel canvas. Do I need to give it some width and height, or the Java? This code. The pixel canvas currently not showing anything. Yeah, the electrode band pixelated up electrode array. Being embedded in draw function. But this function I just call start button. Okay, make sure I click the button. Yeah, there's an electrode. Okay, this is actually not there. The big square not showing any electrodes. Okay, it's still in JavaScript. Bit odd. Okay, let's use that instead. But I changed the order of them. No, I didn't. I should see some electrodes there. There should be a 20 of them. I can get rid of that. Because the JavaScript should be taking care of it. Okay, let's use the workspace handle. Okay, the electrodes are not appearing on the pixel canvas. They're meant to be. Can we make sure they actually appear and change color depending on the amplitude within a certain frequency band of the incoming audio signal? Okay, the main.js, we creates and appends electrodes to the pixel canvas. However, it seems like the element array, which is supposed to hold reference to these elements, is not defined. Okay. So in the draw function, electrode elements array, push each created electrode. This page. So we have electrode elements. Do we? It still doesn't work. Oops, what's jumping like that? Then no errors. There should be. there should be errors. Okay, make sure electro yeah, should that canvas have a certain pixel canvas? Okay, we have the audio canvas, we have the pixel, and then the filter. Currently we're dealing with the pixel canvas, and this meant to be showing a simulation. I'll keep this text should be inside the body, is it? If my document and it could be H2. I don't know why it's not updating live. It should be updating live because it's the Flask application. Yes. Yeah, JavaScript does all the work, doesn't it? JavaScript, make sure the electrode array is visible. The page loads, yes. And let's do it. Workspace handle. The electric is made visible when the page loads by creating a pending division element, which is class electrode. Okay, we have number of a number of electrodes, electrode element. We're pushing 20 electrodes in there. Okay, this is the same, so canvas. Okay, there are this many electrodes, but they're not visible. I think they have no color or something. And make sure the electrodes have background color evenly spaced out, the same size, same shape. Okay. Mm. Same color. Yeah, let's go with that with a workspace handle. Yeah, we'll put them in the same color first, and then they're meant to change color depending on the energy within a certain frequency band. Okay, so we're updating. Set the shape to. Okay, I don't see them. Why? I don't see the electrodes. Yeah, so they're there. Okay, background color is white. Okay, I don't see them. They're not in the right position. Yeah, I don't see the electrodes. I think they might be in the wrong position or something. It's possible the electrodes are not positioned correctly due to CSS properties. We got rid of the CSS properties. Yeah, we're getting rid of that because they did JavaScript. They meant to take care of the CSS as well. Still don't see them. It's really weird. Let's bring the try Gemini. So we're not using GPT-4 today. We're using Gemini and GitHub Copilot. You're absolutely right. To ensure electrode array is visible properly style, main issues that the code was attempting to append elements to a canvas, which is not designed for that purpose. Okay, we'll append to the pixel canvas division you created. Well, that works, right? Pixel canvas. Well, what we currently have is not working, so we might as well. So we're changing. Yeah, we do want to create the layout. Now that error is okay. So essentially no errors, but it doesn't work. Wait, should this be? Yeah, there's some sort of structure. Just ask Copilot. So ready file before the script runs, you can. Yeah, there's a structure to the code. Okay, what we currently have doesn't work, so okay, let's comment this out, place that code. Yeah, it should be a grid like that, but never mind, we'll sort it in a sec. As soon as we have any electrodes going, we will be happy. Where is it getting that from? I know, it is legit. Function draw is in it as well. Oops. Yeah, just copy pasting from the commented out. Okay, now we stuffed something up. That function. Do we need that function initialize? Don't think so. Okay, I still don't see the electrodes. Okay, now just doing random stuff. And let's start a new Gemini. And Copilot with the workspace handle, so it looks at the whole code. Now the pixel canvas, pretty sure is visible. The electrodes might not be visible to the cut. Yeah, it should have a red background color now. Yeah, we don't want to do CSS as a separate thing. The pixel canvas has dimensions already. That should be fine. The number of electrodes. Initialize is not defined. Well, I mean, the only reason 2 by 2 could be Don't need the stop. Wait, it's the bloody array. Should have background color red. Position relative, okay. Don't see any of them. Should be 20 of these bits. Now that is being displayed. See the audio canvas. Okay. But don't see the electrodes on it. That's right. Okay, we're going in circles now. It's better. Hey, we better do something else. Might take 5 and come back in a sec. do last attempt with this one. Yes, it might be the CSS of the electrode array. We haven't changed anything. Yeah, it's assuming. No, we do not have a separate CSS file. All the styling should be in JavaScript code or HTML, but in this case, it's JavaScript. Pix. Okay, style background. Okay, let's go back here. Yeah, we want to check. Yep, the electrode, the canvas is there. Check if the electrode may be being created. Yeah, this should be there. Can go here. So log electrode elements. I don't see it. Why don't I see it? Oh, come on. This. Okay. Being appended. Can check this by inspecting pixel canvas element in the browser. Shift C. Can't copy this guy. Yeah, the electrode elements are being correctly created. However, the pixel canvas Doesn't have specified width and height. I'm pretty sure it does. It does have specific width and height. If you want to create the grid electrode element, should use the element as the container. A pixel canvas. Right. Get the electron. Yeah, we could arrange the electrodes in a different structure. What's called shell-like structure. That's fine. Should we do it now, or is it too hard? Okay, so I see the audio connects. I see the electrodes. Okay. Okay, we need to make sure the electrodes change color based on the audio data. Change the to the array. No, it's no, it's already to the array. Change the electrode position based on the shape of a cochlea. Let's see if it understands. This is all GitHub Copilot. Let's change the calculate electric position. No, we don't need to calculate anything. No, we don't need to calculate the electrode position. We just want to set it in a spiral shape, similar to what the cochlea looks like. Yeah, we need to set up make sure the electrodes are positioned okay, so where existing electrode setup code. How do we do that? How do we do that? Existing electrode. To feel. Okay, wait. This would be going pixel canvas. Where's the pen child? Okay, div existing pixel canvas pen child. It's really hard to modify stuff like that, but we have a way of doing it. Can get rid of that log. Yeah, we comment this out, put the Copilot's code in here, and then fill this up. I don't know why it's just it doesn't do it in a batch. it's, it's just this is what the cochlea looks like. Oh, come on, no. What did you do? It's weird. Okay, the cochlea shape should be just a spiral of about 1.5 turns. full circle divided by what? Full circle divided by the number of no. still, still no. Division and radius. Sine, cosine, angle. How is it even outside the canvas? Should be just a simple spiral. Okay, workspace, a handle. Okay, blah. Initialize. Okay, we need to get rid of it over here, do we? Okay, now we don't see anything at all. Well, that one wasn't good anyway, so get rid of it. Get rid of it. Position of the electrons power shape similar to the cochlea. You can use the initialize function. Yes. A creates a number of electrodes, position them in a spiral shape with 1.5 turns, spiral turns. This is what we already have. So why? Oops. That's how that works. The electrodes are not being pushed. It looks like there's something random to it, but no. Is it changing the size of that canvas? I don't know. Its scaling is nice, but it's not quite what I wanted. Should in theory be in the initialize function. Should be a simpler. Yeah, the radius. What? The radius of the spire is increasing linearly with each electrode due to let radius. Adjust the multiplier. No, the multiplier should be a 1. This creates a spire that expands outwards with each electrode. If you want the spire to stay within this certain boundary, you might want to adjust the radius calculation. Yeah, the main functionality of this is that we want to change the color based on the audio data. Change the color of the electrodes based on the standby in the draw function. Is it number of bands? The activation level is calculated. Average amplitude, then use the background color of each electrode. However, it seems like the amplitude and number variables are not defined. Yeah, we want to calculate the average amplitude for each band frequency. Determine the size of each band. yeah, we'll have to finish this another time. Anyway, the idea is that, yeah, you have those electrodes in a cochlea-like shape, so essentially a spiral. And then the sound is being divided into whatever number of bands, depending on how many electrodes we have. Currently, we only have a 10, so a very old cochlear implant. This, yeah, 20 doesn't really work. Oops. It's just going outside. It's meant to be a. Let's leave it then. Once you, yeah, you need a start button because it won't, browsers will not record your voice from the microphone unless you click something, just like a safety feature or whatever. Should we leave this simulation running? Because I need to go. Question is, should we stop the stream or keep going? Well, live just died out. Had something going on. Yeah. So, yeah, could just. Anyway, I'll have to go. I might leave it this running. Then we see how we go from there. And we get back to this one. And in the meantime, go check out biomedical.com. There are lots of interesting tools. Check them out and let me know what you think. One. I don't know, it's just weird. Is it working? Have to test if it's working at all. Maybe not. I mean, it's doing something. Oops, that's not good. One, two. Something wrong. It's working in general. Oops. It's the main container. Yeah, the pixel canvas, it's super small. Why is it so small, the pixel canvas? One. 1, 2, 1, 2. Oh, come on. The colors are working. The canvas. The pixel canvas size is incorrect.
Explicit pixel canvas size. In the HTML, the width and height are now set directly on the pixel canvas div, using inline styles or CSS. Window load event. The electrode creation code is moved inside a window. Add event listener, load. Block. This ensures that the pixel canvas dimensions are correctly calculated after the page has loaded and the element has its final size. Position recalculation. The max radius, cochlear center X, and cochlear center Y variables are recalculated inside the load event handler to use the accurate client width and client height values of the pixel canvas. Z-index for electrodes. Added Z-index, 1 to the electrodes so that they will always be visible on top of the blue background.
Okay, this is kind of working, but I'm not sure. Ooh. Yeah, so this should correspond. So if you have a very high pitch sound something, it should activate. It looks like two spirals. It looks like two spirals, doesn't it? Should be just the one, and it's only really using the one. So I'm not sure what the alpha spiral is doing there. So why it's repeating the same text if you ask it to. Ideally, it will also start without. This is obviously run 1 2 1 2. Okay, this is what was creating the second spiral, so we don't need that. What else we had and the code just got rid of? One two one two. Yeah, it's behaving a bit weird. It's just obviously responding to clicks and everything. Let's start a new. Yeah, so this is a Flask application. Have this HTML and this JavaScript. We can ask GitHub Copilot to can you rewrite the files and folder structure for this project? 1, 2, 1, 2, 1, 2. Does it look like a cochlear implant? One, two, 1, 2, 1, 2, 1, 2. 1, 1, 1, 1, 1, 2. Yeah, there should have been activation. Sorry for the annoying sounds. But it should have been activation of that last electrode. Yeah, yeah, we need to probably need to filter. I need, oh come on, did it delete the previous? Only a single image file is spotted. Well, that's a big difference to what GPT can do. What GPT can do, big difference. Can upload multiple images and stuff. The response doesn't make much sense. Can you explain the link between the frequency response and the electrode activation? Yeah, it's because of the amplitude of that bit.
The image demonstrates a simplified simulation of how a cochlear implant works by linking the frequency response of a sound to the electrode activation in the cochlea.
That's right.
The top part of the image shows a frequency response graph. This graph represents the different frequencies present in a sound and their relative intensities. Each vertical bar corresponds to a specific frequency. The height of the bar indicates the intensity or loudness of that frequency in the sound.
And by the way, yeah, my stream is using some suppression, noise suppression, whatever, so you can't hear certain things. Yeah, this is me blowing into the microphone. I don't think, if it did go into the stream, I apologize for the annoying noise, but just checking the, yeah, this is blowing into the microphone.
The bottom part of the image displays a spiral arrangement of circles, representing the electrodes in a cochlear implant. These electrodes are surgically implanted in the cochlea, a spiral-shaped organ in the inner ear. Each electrode is responsible for stimulating a specific region of the cochlea, which in turn corresponds to a particular frequency range. The colors of the circles represent the level of activation of each electrode. Brighter, more intense colors indicate stronger activation.
Yeah, that's right. It doesn't seem to work well.
Sound analysis. The cochlear implant processes the incoming sound and analyzes its frequency response. Frequency mapping. The implant maps the different frequencies in a sound to the corresponding electrodes in the cochlea. For instance, higher frequencies might activate electrodes at the base of the spiral, while lower frequencies activate electrodes towards the apex. Electrical stimulation. The implant sends electrical signals to the activated electrodes. The intensity of the electrical stimulation is proportional to the intensity of the corresponding frequency in the sound. Neural signals to brain. The electrical stimulation of the electrodes triggers neural signals that are transmitted to the brain, where they are interpreted as sound.
1, 2, 1, 2. the way, go check out bionicchaos.com. There is a lot of interesting tools. Hopefully you will find them useful, and do let me know what you think. And this one is in the works. Would like to keep it nice and simple. This is probably kind of good enough. But just trying to check if the electrode activation is actually accurate. Yeah, we need to rewrite all this stuff. Let's see. Frequency response to the audio visualization is divided into bands. That's correct. Each corresponding to an electrode. It's pretty accurate. So far, so good. The amplitude of each band is calculated and mapped to a rainbow gradient color. That's right. The rainbow gradient ranges from blue, low amplitude rate, high amplitude. That's right. Average amplitude. That's correct. Spiral shape resembling cochlea structure. The spiral shape is achieved by calculating angle radius for each electrode. The electrodes are evenly spaced along the spiral, creating a visually appealing layout. Okay, if you say so. Each bar, let's go. Yeah, here's where it starts to hallucinate a bit. Yeah, there's a start button, which we really want to get rid of. Don't really need it. Start button, the audio visualization. Yeah, so it's obviously interactive in the sense that it's your voice. Sound analysis, web audio API. Sounds correct. That is processed. Note to obtain frequency amplitude values. Divided into bands. Average amplitude for each band determines the color of the electrode. So just engaging and dynamic display. Okay, if you say so. Interaction is starting and stopping the audio analysis. There's no stop button. references. What? Web audio API. Yeah, check if it's okay. Okay, I've already been there and done that. Okay, did update the app info prompts, requirements, static. This a more accurate structure. Before we had all sorts of other JavaScript files, and not anymore. How do we test this thing? Draw a function. Number of bands. Don't we have it already? Dead electrode number of bands. Yeah, it's equal to the number of electrodes. That's fine. Frequency band. Calculate total energy. Yeah, we're going over each band. Start frequency, end frequency, index. Sounds legit. Yeah, those are the hue is changing, the color. Yeah, this makes a lot of sense because we do want the like do a ratio, not like an absolute number. Let's comment that out for a sec. Use this for a function instead. 1 2 1 2. I don't particularly like it. Yeah, it's just the way it's being like rendered on the screen, right? So total energy. Is something not quite. Yeah, it's just doing. Yeah, I think that's like a relative thing. That's why it goes to red.
Calculate total energy. We sum up the values in the data array to get the total energy of the audio signal. Calculate band energy. We calculate the energy within each frequency band, corresponding to an electrode. Calculate energy ratio. We divide the band energy by the total energy to get the proportion of energy the band contributes. Map energy ratio to hue. Instead of directly mapping amplitude to hue, we map this energy ratio. A high ratio means the band contributes more to the overall energy, resulting in a color closer to red, high energy.
Need the audio frequency generator. Audio frequency generator. I don't have speakers. How do I put input into the microphone with no speakers? That would be hard, wouldn't it? I have to test it with my voice, but that would be annoying. So just do it with my microphone turned off. Yeah, I think I know what the problem is. We might need some filtering first, because we get too much happening in the lower frequency.
Total energy. The total energy variable gives us a reference point for how much energy is in the entire sound spectrum. Energy ratio. By calculating the energy ratio, we normalize each band's contribution. Even if a band has a low amplitude, it might still have a high energy ratio compared to other quiet bands, making its color more intense. Hue mapping. We use the energy ratio to determine the color. A ratio of 0, no energy, would result in a hue of 200, closer to blue, while a ratio of 1, all energy in that band, would give a hue of 360, red.
Let's see what's live doing. There's something happening there around water. It's all happening. Yeah, we can. Yeah, there's a whole description at the bottom of how this can be improved. Yeah, we will add more controls, but currently, yeah, you essentially can draw with rocks. What else can you do? You can select your water. Life is being generated around water. You can create life near other life. You can just create it anywhere you like. And the life is just drawing rock or whatever. Have to check it. This bug. Sand is doing its sand thing. Is more water should be moving sand around as well. You have keyboard shortcuts for selecting different elements, so that's pretty handy. You can empty stuff, so essentially get rid of any type of component. And the thing that makes it go forever is the fact that water, life is randomly generated around water, so it will just go forever. So beware, there will be really long streams. Well, essentially me taking a break and you watching life form, die, and do all sorts of funky things. This is all open source, by the way. You can just fetch the JavaScript of the page. This is all JavaScript, and run it anywhere you like. And check out all the other blogs and web applications on the website. You'll be helping the project a lot that way. The current RPM is very high as well, so you'll be really helping out. Back to this. Yeah, we just changed the way the energy in each band is being translated. I can't say it made it much better, but it does make more sense in the sense that it's a ratio, like it's an energy ratio instead of a amplitude. So currently, yeah, it's hard to test. Have to Do it a bit better. Do it better. Do it better. Yeah, this can go into the HTML. Yes, full disclaimer, not actually writing anything. Ah, come on, the comments. Silly comments. The silly comments. Please turn this text into HTML text. Hey Johan, how are you? You're doing a model of a cochlear implant. It's a cochlear simulator. You can see how your voice through the microphone gets translated into well, mimicking an electric stimulation on different electrodes. It's a bit hard to, yeah, I don't particularly like those colors. They were better before. So yeah, that red there is because the noise coming through is 100%. Well, it's calculating 100% for that band. Therefore, it's that the electrode is turning red, as if it's being stimulated to the full. But that's not good. Have to filter it somehow. Yeah, we also were doing. Yeah, we have the live going in parallel. So it's a simulation of yeah, live. Yeah, there's a lot of yeah, it's Conway's Game of Life. But then you also have some fancy fluid dynamics going on. Life is being generated around water and air. Well, yeah, so white is air. You have keyboard shortcuts for placing rock life, but life you can only place next to other life, and next to water it will be generated all by itself. Rock stays where it is. Yeah, it doesn't do much. Place rock inside water. What else? Sand. Ah, yeah, we have sand. So sand does this like pyramid-like structure thing, and water meant to interact with it, meant to dissolve it or something. It should also not stay like that on top of water. So yeah, we can get the board to improve it slightly. Yeah, this one's been running for like 4.5 hours, still generating stuff. Yeah, we'll essentially generate forever because of yeah, life gets created around the water and air and oxygen, whatever. Meant to be realistic simulation, right? Yeah, there's obviously a robot written description at the bottom of the page. Yeah, go check out our things. I don't know if the camera. Yeah, I should have two cameras. Sometimes they're all the same, two similar cameras. So sometimes I'm having trouble using them. So that's one of the And now one of more recent tools is this vision impairment simulation, so you can essentially see if you can see. Then you can use this to simulate what a vision impairment will look like. And yes, it's simulating different different things. Yeah, the color saturation didn't work. It's not that I was trying to it's not available for like subscribers or something. It just didn't work. It was like just doing something funny. But yeah, you have peripheral vision loss, contrast sensitivity, which is a thing, brightness, yeah, and you can have yeah, camera just stops working. Yeah, it's the two cameras that they like interfere with one another or something. So yeah, check out the website. I don't know, I think John is mainly interested in EEG, I think, is it? There's a bunch of blogs, but earlier tools on noise removal and stuff, but they have to be updated. Yeah, we're doing. Yeah, this inverse noise looks a lot like real like baseline EEG. So you have Gaussian uniform, you have the frequency response of it as well. But the inverse F does look a lot like a baseline EEG. So there's this other tool that we need to improve. That will ideally, yeah, needs to fit the screen as well. Would be nice. That will, yeah, ideally have options to add 1/f noise. There's different names to it as well. Yeah, so I want to do more development on this one. Yeah, the bands idea. Yeah, there should be a whole section on limitations and future directions in there, but it's also yeah. So this one will need way more work. We'll probably leave this tool as is and just add a new one. Sometimes it's just easier. Yeah. So I'm not sure if this is ready to be published or not. Probably not, because we need more description. This is what the robot is doing for us. I don't know why it's placing that H2 always like that. Yeah, blah blah blah, user interaction. But yeah, I'd like to get rid of the start button, but I think it's a feature from within the browser that doesn't let you record from your microphone without you pressing on anything on the screen. So I don't know how it's safe, but apparently makes things safer. But yeah, so it's all work in progress, so your feedback will be greatly appreciated. So it's using 118 megabytes memory usage, just leaving the website open. Must be, I don't know what it is. Yeah, so this one need to filter essentially with this microphone that I'm using. Just seems to me that I just need to filter this a little bit of noise. So do a frequency cutoff of like, I don't know what it is, a 1 hertz or so, maybe. just make the response more flat? No, that will not be good. Let's prompt with energy-based coloring now. Make sure the electrodes change color, yes, but the frequency response. The energy calculation. Yeah, it's correct. And that the color mapping is appropriate. The energy ratio. No, we need to make sure we need filtering. Yeah, once we mention filters, we'll be going places. I don't think we have any filters at the moment, or at least not that I'm aware of. Yeah, we had some filtering mentioned in previous prompts, but and surprise, we're not using GPT-4. Well, not for 2 months or so, because Gemini Advanced is kindly providing 2 months of free trial. So we'll be trying that, but so far I'm just using it like today and yesterday. It's not as good. It's a bit odd. Update electric currents, refine energy calculation. Okay, what did you do? Normalization. Yeah, energy is moving. Yeah, it knows a whole lot about everything. Let's read it because I'm losing my voice.
Total energy smoothing. Instead of calculating total energy just once, we recalculate it in each frame. This allows the visualization to adapt dynamically to changes in the overall audio level. By continuously tracking the total energy, the color mapping remains consistent even when the overall sound volume fluctuates. Energy ratio normalization. We now track the max band energy and use it to normalize the energy ratio. This ensures that the most energetic band always maps to the highest hue, red, providing a clear visual indication of the most dominant frequency range. This normalization helps maintain the rainbow gradient effect even when the absolute energy levels vary. Additional considerations. Filtering. If your audio source has a lot of background noise, filtering the data before analysis might be beneficial. You can experiment with simple low-pass or high-pass filters to remove unwanted frequencies.
Okay, let's check this code. Yes, we're doing refining the energy calculation. Fine. And the audio should be back, and it should be closer to the microphone as well. Now I'm using the bot. Sometimes I'm losing voice, so I have to use the bot to do the talking. Well, currently it does the coding as well. What we're doing? Yeah, refined energy calculation. So we have the number of bands. Here should be the same as the same as the number of electrodes. So we don't actually need number of bands, but okay. Same numbers, the number of electrodes, frequency bands. Yeah, that's the same. Calculate total energy. Okay. Leaves moving. Total energy, waves moving. Should we just take its word for it? No, the main problem is that sometimes there's obviously placeholders in the code. We don't want those. Get them off. Okay, I'm essentially doing all that. And date going all the way. Hopefully there's no placeholders. Best way to test it is just run it. Okay. So this is a bit, well, the colors are more interesting, that's for sure. Let me turn off the microphone for a second because I just want to do like a squeaking noise, see if I can get those upper electrodes activated as well. Well, I cannot because you still have a fairly large component there at the low frequency. Yeah, because of the background noise. So question, do we need to get rid of that background noise first? I know most engineers will say yes, but yeah. One. Yeah, so the main difference now that became more colorful is supposedly because it's calculating the overall energy all the time. So it is better for each frame, not just once. Use the normalized energy ratio. This ensure, filtering if your audio source has a lot of background noise. Well, so mine doesn't have a lot of background noise, but there is some. Yeah, low pass or high pass to remove. Might just give it as an option. Never hurts. Can turn it off. If we're doing both low pass and high pass, okay, if we're doing both low pass and high pass, do we give an option to the user to turn it on and off? What the what the cutoff frequencies should be? Yeah, there's obviously, well, not obviously, I don't know why. There's no text to speech or speech to text in Visual Studio Code. If the developers watching this, probably not. While it's generating, I might just take a quick break. Yeah, it's interesting how one drop of water can potentially do nothing or generate a lot of life. From a single drop. Okay. Okay, it's a whole, because we already have 150 lines of code. Yeah, if we start filtering stuff.
Filter setup. We create low-pass filter and high-pass filter nodes and set initial values that don't affect the sound. Full range. Filter controls. Checkboxes and sliders are added to the UI to allow the user to toggle the filters on, off, and adjust the cutoff frequencies. The checkboxes enable, disable the corresponding sliders. The sliders update the filter frequencies when adjusted.
Yeah, it becomes a whole separate project if you're adding a lot of filtering and stuff. You have to keep it simple.
Update filter connections. This function handles the logic of connecting, disconnecting the filters based on the checkbox states. The goal is to only have the active filters in the signal path to avoid unnecessary processing. Low pass. Start around 10,000 Hz and experiment. High pass. Start around 100 Hz and adjust. The ideal values depend on the type of sound you're analyzing. Place the filter controls in your index, HTML, where you want them to appear. You can add labels to the checkboxes and sliders for better user experience.
Yeah, that's not a bad idea. So this is all additional code, your existing code, electric setup, audio setup, etc. Filtering. Why is it not in a separate function though? Should be all in. So those are definitions for the filters. Check it's still working. Yeah, we obviously need to update the HTML as well to add the filters. Okay, we have the main container. Just comment it out. One two one two. 1 2 1 2. 1 2 1 2. One, 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 one. Does it do anything? That's where Copilot should be better. Okay, let's see. Let's see how well. Gemini is handling errors. Something in the structure of the code. Filter nodes, load bars are being created outside the scope where audio context is available. Wait. Oh. Yeah, we need to rework the whole code structure.
Filter variable initialization. The low-pass filter and high-pass filter variables are now initialized to null. Filter creation inside start button event. The filter nodes are created only after the audio context is initialized, ensuring they're created in the correct scope. Update filter connections with null check. A check has been added to the update filter connections function to ensure that the filter nodes exist before attempting to disconnect them. This prevents the error you are encountering.
One, two. One, one. One, one, one. 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 Why on earth do I have them twice? One. One, one. One, 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 one. 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 One, one, one. Okay, there's something wrong. this was placed from within JavaScript, was it? It would be nice to see if it's actually working. It would be nice to see if it's actually working. Can't tell. I don't think it is. Every time. Okay, every time you hit the start button. That's not good, is it? Not good at all. Anyway, we'll have to continue this next time. I'll just say bye-bye for now. Bye. Go check out the website. You'll be helping the project.